This is the drive-by-wire throttle control system. This system employs a double throttle position sensor, as well as a double accelerator pedal position sensor. As we can see on screen, an electric motor is attached to the throttle plate shaft. This electric motor is commanded by the ECM, or the throttle control computer, according to the pedal position sensor input and the feedback from the double TPS. There is no physical connection nor cable between the driver and the engine with these type of system. The dual, or sometimes triple, TPS sensor is manufactured in this way for redundancy or in case one of the potentiometers fail. In such a case, the computer would use the redundant TPS to allow the driver to reach the nearest repair shop, albeit at reduced performance. Drive-by-wire systems are employed for a few reasons. One of these reasons is that the ECM is in full control of the throttle activation. This falls within the principle of torque management systems. Torque management only means that the engine is going to do whatever the ECM wants it to do, and not the other way around. In regular fuel control systems, with throttle cable, the driver presses on the accelerator pedal, the throttle plate is actuated, and the throttle position sensor gives an indication of aperture. Once the ECM sees that, then it will make the appropriate corrections as necessary. Again, there is a specific reaction lag time between the computer receiving and making the proper decisions and adjustments. This poses a problem when it comes to fuel efficiency and emissions output from the engine. That erroneous engine operation, although very short, has to be absorbed by the catalytic converter and the rest of the emission control components. Over time, and multiplied by millions of cars on the road, it adds up. The drive-by-wire system is employed in order to protect the catalytic converter, raise emission standards, and give the ECM a wider control of the torque produced by the engine. The process of accelerating an engine is therefore now done entirely by computer. This allows the ECM to modify injector pulse before it actually opens the throttle plates. Never before has this level of control by the ECM been seen in an automobile before. The other reason for drive-by-wire is that the idle speed and cruise control operation is entirely done by computer using the drive-by-wire electric motor. So, by using this systems, all the associated components related to the cruise control system and the IAC, or idle control valves, are eliminated. This means a reduction in production costs for the manufacturer as well as higher profits. Drive-by-wire systems, in the vast majority of cases, do not employ an IAC valve. The idle speed is fully controlled by the electric motor, which makes the problem of carbon deposits on the throttle plates much more important. And a final point to remember about drive-by-wire systems is that they are totally integrated with the rest of the vehicle module network. For example, the ABS system is fully integrated with the throttle control computer. In the event of a loss of control of the vehicle by the driver, due to wet road or icy road conditions, the vehicle will simply throttle down. The ECM in effect reduces the torque of the engine, and the ABS goes into action to allow the driver to regain control of the car. This level of safety is done, of course, to control the safety of the passengers. This level of performance and safety also has a great deal to do with insurance companies pushing for the technology, which does work. The system is not there to simply increase the complexity or cost of the vehicle. In actuality, they do lower the general cost of automobiles, while give the driver a much higher safety margin